Hey guys, welcome back into the channel. Today we're going to do a little project where we're going to take this portable record player that's portable in that it's nice and small, it's a briefcase style, but it still requires a plug-in adapter, kind of like one of these USB bricks here. This is a little different than some of the other ones in that it doesn't do 12 volts, it actually does 5 volts off of any USB. So we could just add a battery bank and run it externally and it would be just fine. But I still wanted to be a little more mobile, a little not have to think about that part. So we're going to take these two batteries and we're going to put them inside here. Now there should be plenty of space. The only thing inside of here is probably a small circuit board and these little speakers that aren't the best in the world, but they do okay. This model has Bluetooth capabilities, a headphone jack. It has a lift arm, which is pretty nice. And in the back, it's got some of the standard connections. It's got the power. It's got a USB, which can actually take the vinyl and then put it onto USB in a WAV format, which is pretty cool. And then it's got the output, so you can hook it up to stereo system. I have hooked it up to a bigger speaker, and the quality is quite good for a little $50 unit like this. So there's a couple ways I could have approached this as far as the batteries. Since it only needs 5 volts, you know, I could overshoot the voltage by a lot and use a circuit board to reduce it down to the 5 volts. Or I could use a smaller voltage, like these are 3.2 kind of nominally, and bump it up to 5. And that just required another circuit board and such. And I started to play around with it and hooked it up to my variable power supply. And I was able to bump it up to 7 volts without any issues. It still ran fine. The speed of the record was fine. And so what I thought is, since these are nominally 3.2, after you kind of fully charge them, I could put these in series, and that would give me, you know, like 6.4, but I'll bump it up to 7 to charge. So I'll lose a little bit on the top end, since normally these charge at 3.65. So I'm only going to charge them at 3.5 each, totaling 7. Now we do need to take care of these batteries and make sure they don't deplete or overcharge. So we're going to add this 1S BMS to each and then series them together. So hopefully when we take this apart, we'll be able to see on the power side some nice little solder joints we can run wires to and make this a nice little pack. And so that's the next step. We're going to take this apart and see how much space we have to work with, look at the circuit board, and check that we can get power to that outlet. And the cool thing about running it to the PCB board or the outlet port is that we'll be able to charge it using the exact same port. And so, or right here. And so what I'll use is I have a custom power supply that can do multiple voltages, or I could use my bench power supply, and I have plenty of power supplies where I have variability. So I'll just pump 7 volts into there, so to charge it and even to run it. So that way I don't have to kind of play with it back and forth. So let's crack this sucker open and see how much space we have to work with. All right, that was simple enough. There were just 4 corner screws that would connect at the top here to the base, and as you can see, it's mostly hollow, so we have plenty of space. We can put the batteries here in this orientation. And so what I think I'm going to do for mounting these, I think I'm just going to use super glue to connect them to the board. So if I had to pull these out because something else failed and I just wanted to reclaim the batteries, you know, I could tear off this shrink wrap and redo them for the next project. But I'm hoping I can use this for years. So the next step here is to pull out the PCB and probably get some wires off of the power port, which is right back here. And I'm pretty sure I can get to the solder points underneath the board there. So I'm going to take some pictures of these connectors so that I can pull the board off and not have to worry about those cables, and I'll know how to put them back. So let's go ahead and work on that. All right, we were able to remove the little logic bar part of the system, the PCB that handles the power and the USB and aux and all that stuff. And so there it is. Right here is the power. So with my multimeter, I quickly tested which one's which using the supplied power supply. So that glob right there nearest the wall, that's the ground, and then that's the positive. I tried pulling the board off so I could get a nice clear access to that little blob there, but that looks like this RCA connection is like glued, so I don't want to destroy it. I don't want to break it. I may chip away a little bit of this plastic so I can get in there, but I'm going to try without it. But I might melt something. But this is all it's got a large flange on it, so it'll hide anything. So it'll still look factory new. So I just got to do is run a ground wire from that glob there, and then run a positive wire from there, and then attach them to the battery BMSs, and we'll be good to go. So let me add those wires now, and then we'll go to the next step of adding the BMS to the batteries and go from there. So this is a short project, but it's a pretty cool one. So hope you guys enjoy, and let's keep going forward. All right, as you can see here, we've got the wires tapped on there. I went ahead and hot glued to keep them safe, make sure nothing kind of lodges loose or any piece of debris that could be conductive, could short that out. And then just added a bit of tack here just to keep the wires organized. So the next step is we're going to take the USB or the BMS connectors here, run the positive negative off of here, and then leads off of these two pads. These go to the battery, and then this is what you get out of the BMS that protects it. So these will go in series with another one of these. So I'm going to take a little bit of wire and a brass washer, and those will be our leads to connect to the battery, and we'll just hot glue them. Haven't decided whether to put it on top or maybe on the sides. Depends on, I have to remeasure some of the space. If I put it here, I know it will be fine. If I put it up here, there might be a pinch point. So most likely, I'm just going to put them over here. One battery is going to be in this orientation, and another battery is going to be in this orientation. And so we'll just have to, run negative off of one side, positive off the other, and then bridge the two BMSs together. So let's work on that now. All right, we've got our wiring done here. Let's take a look. So off of the port for power on the PCB here, we have our wires. Positive goes all the way to this BMS, and this side of the BMS is what's outputted, and then that's what's inputted. We have a bridge from that's ground to this one's positive. So that creates a series battery pack. So the total voltage will be around 7 volts or 6.4 nominally. And so these two leads go to this battery. The two leads off here goes to this battery. And that gives us our protected power system. So if they drop below, I think it's 2 volts or 2.2 or something like that, it'll save the battery from fully being depleted. So the last step is to install the batteries, glue them down, connect the ring connectors using these flanged bolts with nylon thread lock in them, so they should never come loose. So that's the last step. Let's get it done. All right, before sealing everything up, I wanted to give it a quick test to make sure everything was working. So we've got our leads connected, and we have the PCB mounted back on there. And to test it, I ran a power cord. Sorry, it's hard to see. To the input, really, just to make sure that we were getting voltages. So we got 6.55 volts, which is basically 3.23 or something like that. It's nominal voltage on both batteries. So now I'm going to go ahead and seal it up, and let's give it a test. All right, it's fully assembled. Let's take a look, just to make sure that there's no funny business here. There is nothing powering this except for the batteries inside. So let's power it on. All right, that's a good sign. We got our light. This is a 45. I'm only going to play a few seconds so I don't get copyright struck or any of that stuff. Let's see, it's spinning. I'll just jump in the middle here. Oh, there we go. All right, that's working well. Let's make sure it goes into Bluetooth mode.
Bluetooth mode.
Very good. Well, I'm sure you're curious on how long these batteries will last, and let me tell you a little bit about the batteries. I got them from Battery Hookup. If you want to buy anything from their site, you can get a 5% discount using my code TECH, T-E-C-H. I'll have that on the screen. And they are 25 amp hour LiPo 4. And so they'll last a while. This is a very low wattage system. So I'm going to just start ripping some of my old stuff onto USB, and I'm just going to keep going until the battery dies, and I'll try to give you guys an idea of how long that will last. But I'm thinking almost days. I bet you I could run this two to 3 days just having the motor running or something, and just see what happens. But I'll update the description when that happens, and I'll give you an idea, but I really feel this is going to run for a long time. So if you like the project, I appreciate a thumbs up, and you know, I'd love to hear your comments and love to see if anybody else modifies theirs to do the same. All right, guys, you have a great day.